So I'm going to ask you to do the first one as a starter. Let's just try. Yeah? The question says, insert 4 numbers. 4 numbers between 3 and 12. Between 3 and 12, so that all the 6 are in AP. I want you to try this on your own first. Let's take 3 minutes. Then we can do it together.
What's the AP?
Say that again.
What's the formula for the AP?
I can't hear you. Speak louder, please.
What's the formula for the AP? What do you mean by insert 4 numbers between 3 and 12?
Okay, you have 3, you have 12. Put 4 numbers in between them, so that all the 6 are in AP. That's the question. What exactly is she asking? Kindly. Have I answered your question?
Alright, she's explaining, I think.
Let's try that quickly. You have 3 and 12. Put 4 numbers in between them, so that everything that you now have, that will be 6 altogether. The 2 you have and the 4 that you inserted, so that all those 6 forms a sequence of AB. All the 6 forms a sequence of AB. 2 more minutes. It's just a trial. It doesn't have to be perfect. You can use your try and error method. You can use AP method if you don't know which one to do. So it's allowed for now. But once we do it the AP way, then we have to maintain that. Ready? Yeah. Okay. What are the results? What does the soup and everything look like? Anika, did you do it?
Thank you.
What?
Thank you.
Thinking. Justin?
Sequence
Yeah.
3, 4.5, 6, 7.5, 9, 10.5, 12. That?
That's fine.
Is there a 5 in the middle?
But there's like 7.
I think she's right. I think it's right. 4 numbers. Is that 4 numbers? 1, 2, 3, 4. Oh. You inserted 5 numbers, kind of. So who has the 4 numbers? Nobody? Yes, sir.
4.8, 6.6,
4.8?
yeah,
Uh-huh.
6.6,
Mhm.
8.4, 10.2.
How do you get that? Can you explain to us? Or just try?
Oh, yeah, I use the formula as, because 3 would be the first term, right? So it's A plus D equals to 3.
Say that again.
I use the formula, and the first term is 3, right? So
Mhm.
it's A plus D equals to 3.
So A plus D equals to
Because the formula 1 minus 1, so A plus D would be 3.
A plus D equals to 3.
Oh no, A is 3.
A is 3. Okay, A is 3. This is what it's talking about. Hold on before you continue. We have 3. Then we need to fill in these spaces. Right? Okay, so assume that this is A. Then this is what? A plus
1.
A plus 1.
No. A plus D.
A plus. Is that what you did? You tell me what you did.
Oh, I don't know how I got the right answer if I did A plus D equals 3.
A plus D equals 3. Oh, okay. Anyway, let's see. Now this, you don't have to call it A plus D because once you call this A, you mean this is the first term. But we don't know if there are previous terms, right? But it's not a crime to call it the first term, but it's just that this may not be the first one. But the question never said 3 is the first one. But we can assume that between 3 and 12 is the entire sequence. Then we can say 3 is the first one. So I'm not saying you're entirely right, but it may not be the first term too. So rather than do that, just ignore whatever it is. To get the second one, you have to add D to this one. Whatever D is. Yeah? So this one will be 3 plus D. So instead of A plus D, this will be 3 plus D. This will be 3 plus what? This will be 3 plus 3D. This will be 3 plus 4D. And this should have been 3 plus 5D. So you solve this equation.
Oh.
Okay? So 3 plus 5D, which is the system. Okay? So if you call this first indeed, that's just like a system. Okay? So 3 plus 5D is 12. 5D will be 9. And D is 9 over 5. That is 1 point what? 8. And with that, you can find the missing one. So 4.8 is right, 6.6 is right, and so on. Okay? So you can complete it yourself. That's how to insert. Okay, so I'm going to give you one more on that. Insert 3 numbers. Please note that I didn't complete the solution. Okay? You'll complete the solution later. You can put some spaces. Just to, now that we have D, just find out what each of them will be. Okay? And substitute it there. That's it. On the first one, there's 3, 4.8, 6.6. What's the next one? Can you give me that? 8.4. 7.2. 12. So this is a conclusion. Let's put that. So now try it. Insert 3 numbers. You're done with it, please. Okay, so please try this. Can you see the difference between sequence and series? The sequence is just that list that we've been working with. Joey?
Yeah.
The sequence is just that list that we are working with. Series is when you begin to add the numbers. The series can either be finite or infinite, just like your sequence can also be finite or infinite. Finite sequence means it has an end. Infinite sequence means it is endless. We'll talk about infinite series, especially in GP, geometric progression. That's the next thing after arithmetic progression. Yes, sorry. 1 minute.
Is it if arithmetic series is it just that it doesn't have
Arithmetic series means, infinite means it is endless, but you don't know the pattern of the endlessness. Is it arithmetic? Is it geometric? You don't know. Yes, sir.
Should it be 14?
Is it 14? Yeah, 3. Yes, thank you. Okay? So what we're interested in is the sum. Okay? The sum of an AP, okay, is what we want to talk about. And that sum is denoted by Sn. Okay? The sum of an AP denoted by Sn. Can you see how I wrote my Sn? S subscript n. Okay, just like Un. Okay, subscripts. Where n is number of terms. Where n is the number of terms is given as follows. So let's bring out what our sum will be. Let's do this together. Everybody, I need you to stop writing. I need you to stop writing. What does our AP look like in general? Give me. Yes, somebody. What does our AP look like in general? That's, where did you leave that? Why do you say 1, 2, 3, 4, 5? Yes? AP. I never said add them together. Our AP is what?
UN equals.
UN is not our AP. UN could be for anything. What is our AP? The terms of our AP? Yes, else. A plus D, A plus 2D, and so on. Does everybody get that? So I don't know where you got your UN from. United Nations? UN is just a notation for nth term. The nth term could be for AP, GP, could be an harmonic sequence. Okay, it could be any sequence. Alright? I'm asking specifically for AP. What is the pattern? So if I write UN, you don't even know if it is for arithmetic or not, right? But once I write A plus D, A plus 2D, you know this is arithmetic sequence. Do we get my question now? So, our AP, the terms of AP are A. So I'm going to say, given the AP, A plus D, A plus 2D, A plus 3D, right? Up to the last term. Okay? Up to the last one. Remember, we're talking about the entire AP. So, she's number 1, it's number 2, number 3, and maybe she's the last person. Then we have considered everybody. Okay? We're interested in the summation from the first to the last. And that will be the sum of the AP. Do you agree? I don't need to say sum of the first 4, sum of the first 5. Once I say sum of the AP, it means add from the first term to the last term. Do we agree with that? So, that's right. Please don't write. So the sum. You know, remember we already said Sn is sum. So I'm just going to say Sn is equal to, then I add them together. I had the second one. Elsin, if you need to move to this side, please do. Okay? A plus 2D, A plus 3D. And I will continue to add until I add what? L. Okay? If you pick your pen again, I'll keep you out of my class. Does this make sense so far? Now, if these are the APs, like this one, 2, 5, 8, 11, 14, right? So my sum, normally, because there are 5 of them, so it will be S5. 2 plus 5 plus 8 plus 11 plus 14. Sum of the first 5. So I don't need whatever that is the rest. Is there a way I can write this sum again? Okay, maybe that question is too whatever. I could write from the back. That's the point I want to make, but that would not be so direct. Yes?
Do you mean like 2 plus 2 plus 3?
That is like, say, a partial sum. No, that's not what we need here, but you're right. I could write it from the back also by saying, oh, I start from the last one, then I pick the second to the last, then I pick the third, then I pick this. Will I get the same thing?
Yeah.
So I could start from the back, right? Starting from the front, the terms are A plus D. If I start from the back, the last one comes first. What is the second before the last?
L minus D.
L minus D. And the next one will be? And the next one after that? And the last one in this case will be what? A. That's right now. So Sn can also be L, L minus D, L minus 2D, L minus 3D, and this continues until I get back to A. Am I making sense so far?
Yeah.
Now these are 2 equations. Let's add them together. What do you notice when we have these 2 equations? D cancels. Thank you. All the 1D, 2D, 3D, right? Cancels. And each of this addition leaves me with A plus L, right? From this second one, A plus L, right? From the third one, A plus L. From the fourth one, A plus L. Up to the last one, A plus L. How many A plus L do you think we have here?
N?
Are you sure?
No.
Are you sure it's not N minus 1?
Yes. No. Wait, what? It's not N minus 1. It's every single one.
You're sure there are N of them?
Let me say.
Not N minus 1 of them, because you know, N minus 1 is a common thing in this formula.
No, but normally when it's N minus 1, the first one doesn't happen.
You see, it's N, it's right. If you had N terms, you will have reversed it N times again. And you'll be left with A plus L N times also. The first one doesn't have a coefficient, right? That's why the last one is usually N minus 1. But remember, you already added the first one too. So there are N additions. So rather than say 6 plus 6 plus 6 plus 6, for example, in this case now we can see it here. 16, 16, 16, 16, 16. Instead of saying this, what do we say? Oh, 6 times 16, because there are 6 of them. Is it 5? Do you understand? So in this case, this will be 2Sn. Agree? Yes. So 2Sn is equal to n times A plus L. So if I need to find the sum of my AP, I do n divided by 2 multiplied by A plus L. So if we know the last term of an AP, if we know how many terms are involved, and we know what the first one is, we can get the sum of everything. That is one way. From this, we can extend it further because this does not have anything to do with one of the variables that is very popular. What is that?
XD.
Common difference. So if the common difference information is available, what can we do? We can extend this by just substituting what L is. What is L normally? Rita, please. What is L?
Last term.
Yeah, I know. What is the formula for last term? How do we get last term?
You rearrange
No, what I mean is, you know how to find, you know how to find n term, right? How do you find last term?
Substitute the L with the last term.
You're not getting my point. From your formula, A plus n minus 1 into D, that's for n term.
Yeah.
How do we get the last term? I didn't ask you what n is. Yes?
A plus open brackets n minus 1 close bracket.
So you say the same thing? Is it the same thing with the last term?
Yes.
Said yes? Why?
Because last term is also a part of the arithmetic progression.
Yes! Is the last term not one of them? N term is like saying, call me someone. And you end up calling the last person on the line. Isn't she someone? If our position is just a bit, special, right? In the sense that, you cannot miss out who the last person is. But you might make a mistake bringing the 4th person instead of the 5th person. But there's no way you can mix the last person with anybody else. That is just the last position. But she's also someone. So if the general instruction is, this is how we call someone, and you end up calling the last person, have you done anything wrong? No. Do you understand that? So what they are saying is right. Your last term is also A plus n minus 1 bracket D.
I put that formula there.
Maybe you shouldn't do that because you are distracting my class. You can choose to do that on your own, but don't distract my class with it. Does everybody get what I'm trying to say here? I expect everybody to pay attention and reason along. You are putting the formula. These are the things that people do that I don't like. Why is this important? Let's put it back here now. Then Sn will now be n over 2, because it has its own bracket, so I'm going to use the square bracket. Instead of A plus L, I use A plus n minus 1 D. Do you agree?
Yes.
So if you check some textbook, your IB textbook next year, or maybe the IB exam booklet, you might end up seeing this and what I'm about to write, or maybe one of them. So it is Sn, n over 2, open the brackets, 2a, n minus 1, d. And these two are useful to find the sum of AP. Okay? I'll give you an example because of the time. I'll give you one example. Find the sum of, the one example I'll give you now is, find the sum of all multiples of 7 between 100 and 1000. Without AP, that would have been too difficult of a task to do. Of course, you might find some tricks, some shortcuts. Okay? But let's see how we can do that. I'll just put it here. So we don't have to erase any part. Then I can send you something to try later. Okay? If necessary. Let's see. An example. Find the sum of all multiples of 7 between 100 and 1000. Who has an idea what to do first? Richard, you want to walk around? I don't like it when people sleep in my house. Okay. Who has an idea where to begin? Just try. It doesn't have to be perfect, whatever you say.
A7.
Say that again?
A7.
A7. Is it right to say that?
Wait.
No,
Between
D is 100. D is 7.
So you can use a trial and error to see the first number that is a multiple of 7 after 100. Check that number quickly. Check 105. You claim 105. It's right. So the first thing you should do is to try to list the pattern. So that would be 105, 112. Because it's going to be plus 7, right? 119. So actually, I can write it in form of series. Plus 112, yeah? Plus 119. I don't need to write too much. Find the last one. Before 1000, check the last one. So just divide 1000 by 7. Then move a step backward, 999 divided by 7. Move a step backward, 998 divided by 7.
994.
994. Confirm that, please. And trust is good.
No. That's why I asked him what to confirm.
Just kidding. Is 994 correct?
Yeah.
So that is the last. So in this kind of problem, you can see our last term is known. Our first term is known. What do we need to use this formula?
Which term is the
No? Which one?
How many times?
How many? Which position is this one? Because the position of this term tells you how many terms are there. If we are on a straight line and Anika is on the last part of the line, Anika's position on the line tells us how many people are on the line, right? So if Anika happens to be number 25th on the line, it means we are all 25 altogether. So n can be seen as position of a term, n can be seen as number of terms in the AP depending on the situation. Okay? So the only thing we need to find out is what is n? How do we find n, guys?
The first,
Like
like the first one, the
last minus
one.
Last term.
First one.
Plus the first one.
No, minus the last one, we divide by 7.
Huh?
Wait, no.
This is not P6.
You
Think like an
It's not the
IB.
127 term.
Use the formula. Stop thinking like you're doing mental math. Alright? Use the formula. What's the formula to you? L equals A plus N minus 1D. Yes? So what is this? 994. A 105. N minus 1, 7. Okay? Then you get, by finding the position of this, is to find the number of this term. Alright? So quickly. 994